So in calculus, we talk a lot about slope, which in two dimensions we think of as being rise over run, or change in y over change in x. But what we're going to introduce in this unit is the idea that there could be a three-dimensional axis where we have an x, a y, and then a z, which you should picture as pointing out of the screen, coming out at you. So how can we talk about slope now when we have three different dimensions that we're working with? We can't really talk about rise over run anymore because now we have rise over run, but then also we have the z dimension of a point. So that's what we are going to try to work on as we think about how to define our x, our y, and our z. So the first thing I want you to think about, because we're introducing the idea of defining a relationship parametrically, is let's say you're running a convenience store and you notice that you're selling a lot of sunscreen and ice cream. Now, you wouldn't think that because you're selling a lot of sunscreen, that's why you're selling a lot of ice cream, right? You wouldn't think that those two are related. What I want you to think about instead is what might be causing such a high sale of those two objects or those two items. Because if you look at a table and you see, oh wow, ice cream sales going up, sunscreen sales going up, you see this in the media all the time. They take some kind of data and try to convince you of something, right? Ice cream sales soar thanks to sunscreen popularity. Obviously, this example is kind of silly because in this case, I think it's pretty clear to see what might be causing these sunscreen and ice cream sales. And again, we can put sunscreen on the x-axis and ice cream on the y-axis, and we can plot our sunscreen ice cream points 2, 4, 4, 8 and make this line. But implicit in this relationship is a third variable that's causing these sales to go up, and that is the temperature outside, right? So if it's hotter outside, people want to buy sunscreen and people want to buy ice cream because they want to protect themselves from the sun, and they also want to have a cold treat to cool down. So we can define our x, our sunscreen, in terms of T, the temperature, and our y, the ice cream, also in terms of temperature, and then that's going to give us our x, y values. And that's what it means to define something parametrically. This is a parametric relationship. Okay, it's two variables defined in terms of a third variable. So this is going to be helpful when we talk about an object that's traveling through the air. So if we have an object that's traveling this trajectory and we want to define where is the object at every single moment, we need to think about where it starts and where it is after a certain amount of time. So in this case, we're going to say that an object traveling in two-dimensional space starts at a coordinate point -1, 2, and then we're going to say after 1 second, it moves to this point 2, 6. So it goes from -1, 2 to 2, 6. And using that information, we want to be able to define where is this point at every single moment in time. So we need to think about how far it traveled in 1 second, and then we'll use that to figure out how far it's going to go after any amount of time has passed. So we can define x of t and y of t. Right? X of t telling me how far in the x direction I've traveled, and y of t telling me how far I've traveled in the y direction. So x of 0, our initial x value is -1, and y of 0, our initial y value is 2. And then the given information said after 1 second, the x value is 2, and after 1 second, the y value is 6. So in 1 second, I've traveled from -1 to 2 and 2 to 6. So my x value has increased by 3, plus 3. My y value has increased by 4, plus 4. And if it travels at a constant speed, that's going to happen every second. Every single second, my x value is going to increase by 3. Okay, every single second, my y value is going to increase by 4. So I have to define that mathematically. So how I'm going to do that is I'm just going to take my initial point -1, and I'm going to add 3t. And I'm going to take my initial y value 2, and I'm going to add 4t. Because now this is going to allow this x value to increase by 3 every time t goes up. This is going to allow my y value to increase by 4 every time t goes up by 1. Okay, so now this is my parametric relationship. This is my parametric relationship. Because x and y are defined in terms of a third variable t, and I can plug in a t and it'll tell me where my x and my y are. So before we continue, I want to introduce vector notation. So if we have a vector, and we use this little arrow above our v, a comma b, this means a vector whose arrow is coming out of the origin and pointing at 2 comma 7. It's a vector that has a horizontal component of 2 and a vertical component of 7. And then those two, the horizontal and vertical components, are going to form this diagonal component that is pointing at 2 comma 7. So that's how we define a vector in 2 space. And this is important because we're going to define the trajectory we're looking at using a vector that's going to point at different places that the object is after a certain amount of time. Okay, so here's again, back to our point that starts at -1, 2 and goes to 2 comma 6. Here's the parametric relationship we defined. Okay, we're going to take that parametric relationship and put it into a vector Q, where we have our x component here and our y component here. Okay, so then the vector QT is going to be this path, this purple path that's pointing off into the distance as time goes on. Okay, vector Q1 is pointing at, or the vector Q1 represents where the object has gone from 0 to 1 second, which is right here. So that's vector Q1. QT is going to go on indefinitely. So let's examine different times here. So here is vector Q0, where we plug in 0 for t. And if we plug in 0 for t, we get -1 and 2. That's our initial points. And so then we have vector -1, 2, which points right here. Okay, it points up like that. Okay, now we plug in t equals 1. Okay, we plug in t equals 1 and calculate. We get -1 plus 3 is 2. 2 plus 4 is 6. So then now we have vector Q1 is going right there. And again, those components form this diagonal vector. Okay. And then if we look at t equals 2, we have vector Q2, which again, we plug in 2, we plug in 2, we get 5 comma 10. And now we have a new vector that's pointing at 5 comma 10. So then if we look at just vector QT, okay, vector QT is the result of all these different vectors pointing at where the object is after a certain amount of time. It's pointing there, it's pointing there, it's pointing there. As time goes on, this is the vector QT is pointing at all these different points that are going to end up being on this diagonal line here. Okay, so then if I went to Q3, again, I would go over 3 more, I would go up 4 more, and that would take me to the next point on this trajectory. Okay, so here's vector QT. So what about 3 space now? So now we have a point at -1, 2, 2, x, y, z, and it's going to move to 1, 3, -1, and we should specify that this is after 1 second. See if you can define x of t, y of t, and z of t. Given this known information, this is a good time to pause the video and try to come up with this parametric relationship yourself. And once you have it, you can hit play again, and you will see an answer. Okay. So here we go. We start at -1, 2, 2. And then what happens in the x direction? We go from -1 to 1. -1, I should not use black on black there. -1 plus 2 equals 1. So we added 2 in our x direction, and that's going to happen every second. So we do plus 2t. Okay, what about in our y direction? We started with 2, and then we went to 3. So we did 2 plus 1 equals 3. So we're increasing by 1 unit every second, so that's just going to be 1t, which we can just write as t. And then finally, in the z direction, we had 2, and then we went to -1, which means we must have subtracted 3. So we're going to subtract 3 every unit of time. So we have 2 minus 3 equals -1. So then we have -1 plus 2t, 2 plus t, and 2 minus 3t are how we define our x, y, and z for a point following this trajectory. And then if we want to put that in vector form, we say vector qt is x of t, comma, y of t, comma, z of t, -1 plus 2t, 2 plus t, and 2 minus 3t. So this tells us every unit of time where is the object moving in the x direction, the y direction, and the z direction, and vector qt is always going to point at where the object is after a certain amount of time. So that is how we model something traveling through space, either in 2 space or in 3 space, by defining its coordinates parametrically based on time.